now let's bring in the physics. And this is pretty big, what we're going to do here. We're going to do the work of Newton, Isaac Newton. A ball is thrown upward. Actually, we don't want ball, we want the proverbial pebble, or arbitrary pebble. It's thrown upward with an initial velocity of 64 feet per second from an initial height of 80 feet. And one more thing, the acceleration, we're on Earth, acceleration due to gravity is negative 32 feet per second per second. We'll stick in English units just for the purpose that everything's an integer. We could do the same problem in converting to meters. What we want to do is find the position function of the bobble. This is a constant, the acceleration due to gravity. That can be measured, by the way. So that's a measurable thing. Acceleration due to gravity is negative 32 feet per second, feet per second squared. So let's start with that. Acceleration is negative 32. We established the relationship between position, velocity, and acceleration in the first semester. So to go from acceleration to velocity, I've got to take an antiderivative. Because to go from velocity to acceleration, you take a derivative. Acceleration is the rate of change of velocity. So if I take the left side and the right side here and take the antiderivatives of them, I should get a velocity. So velocity equals indefinite integral, negative 32 dt, that's our variable. This is the easy one to solve for. Negative 32t plus c. I need some sort of initial condition to find out the c. Thankfully, I'm given it. Initial velocity of 64. Sub in the point, 64 for the velocity, as long as t is 0. That gives c to be 64. So now I've got a velocity equation. Velocity is negative 32t plus 64. So this is satisfied, and that is satisfied. In a likewise manner, we want to go from velocity to position. So the derivative of position is the velocity, which is given by negative 32t plus 64. We don't want the derivative. We want it. So let's take antiderivatives. Antiderivative of a derivative is the function itself, and then antiderivative of this side. Here we go. Position is negative 32. That can be a constant. And I want an antiderivative of t. 1/2 t squared. Plus, let's use our sum rule here. 64, that's a constant, so that's pretty easy, 64t. And then don't forget the plus c. Half of 32 is negative 16t squared plus 64t plus c. That's the general. Now I will use the initial condition from an initial height of 80. So 80 is the position at t equals 0. So I'm subbing in the 0. It's easy to see that c is 80. So now I can write a specific or particular solution to this, that the position is given by negative 16t squared plus 64t plus 80. And now we could answer all sorts of questions, like what's the highest the pebble goes, when does it hit the ground, what's its velocity, position at certain times. I could be general. This constant stays true for all objects in free fall around the Earth. These numbers could change. I could just make it some sort of constant and do the same process. And that is how you come up, or Newton came up with the general form for free fall equation, negative 16t squared plus the initial velocity times the time plus the initial height. Initial velocity, initial height. That just comes from two antiderivatives starting with something that's measurable, the acceleration due to gravity. So we've derived a vertical free fall equation. One last example. Hopefully you're becoming comfortable with the idea of using an initial condition to get the specific, the particular solution. Suppose particle moves, travels on the y-axis with velocity given by sine 2t. And the initial position, the initial condition at t equals 0, it's 2 units above the origin. Of course, we want to go backwards, so you could guess that we're going to find the position function. Here goes. Position, so the y coordinate after t seconds is given by the antiderivative of the velocity. This takes the form of sine u. Antiderivative of sine u has something to do with cosine u. Now let's check this out. Derivative of cosine u is negative sine u. So I need to undo the negative with a negative. So negative sine u, but then times u prime. The derivative of 2t is 2 That's not over there, so something must cancel it. It's a 1/2. There's the general. Use the initial condition to find the value of C. But let's collapse that first. Okay, now let's sub in. 2 is the position after, or not after, but right on 0 seconds. 2 times 0, that's 0. Cosine of 0 is 1 times a negative 1/2. That whole term evaluates to be negative 1/2. Add 1/2 to both sides, C is 2.5. Now I've got a particular solution for the position. Y of t equals negative 1/2 cosine 2t plus 2.5. That is the lesson. Let's review a little bit. 2 objectives. Find antiderivatives that follow directly from derivatives of basic functions. Rate yourself on that one. Let's go a scale of 1 to 10. 10 being you know it perfectly. 1 being like you have no clue. I'd like to know where you're at that. Rate yourself. Also on number 2, find specific antiderivatives using initial conditions. Take a moment, put down where you are in that. Scale of 1 to 10. 10 being you get it completely, 1 means you have no clue. Thank you for your attention. Remember, you know your calculus. You plus me equals us.